Alright, in this video we're going to look at the DMA 10 test review. This is going to be a lengthy video, but you can scroll to the question of your choice. Well, not scroll, but you can fast forward the video. I will cover all the questions on the review to help you prepare for your module exam. As you can see, all of these will be covered. If you know how to do a particular problem, feel free to skip to the one that you need help with. Let's start with this first one that's on your test review. We want to represent the following with a sketch on the number line, and we want to assign integer values. Question A, we're going to use this number line. 10 degrees above 0, there's a dot right there for 10 degrees above 0. You could think about it as a thermometer, where you would actually have a thermometer outside, just a quick sketch where you have like Fahrenheit and Celsius, and if 10 degrees, if 0 was here and 10 was right here, you would, shade all that in because that's 10 degrees above 0. But on a number line, it's fine to put it there. We also want to assign an integer value to that. 10 degrees above 0 is a positive 10, so we can just write 10. We automatically assume it to be positive if we just write 10. Question B says a building foundation 15 inches below grade. 15 inches below grade means we want to be at a negative 15, and when we assign a integer value to that, we do want to write negative 15 there. Notice this number line down here. I have it increasing in increments of 5, 10, 15, 20, and negative 5, negative 10, negative 15, and negative 20, just to save some space. So feel free to do that when you make a number line, as long as you label each tick mark correctly. So that's question number 1. Question number 2, we want to represent the following as a problem and find the solution. If you lost $29, I'm thinking negative 29, and then you gained $18, that's going to be a positive 18. What is your net loss or gain? So we're setting this or representing this as a problem. We can set this up as negative 29 plus 18. That's all you want to do there is, and think about this. If you lose 29 and then you gain 18 of it back, you're still in the hole. Well, how much are you in the hole? And the reason why you're still in the hole, because you lost more than what you gained. You're still $11 in the hole, because if you take negative 29 plus 18, you do end up with negative 11. Question number 3. Now, actually for this one, your net loss or gain, let's actually be a little bit more precise with that. The answer is negative 11, but let's say you can say I am $11 in the hole. Or I have a net loss of $11. Either way you look at that, I would accept either one of those answers, but since it does say what is your net loss, you do have a net loss of 11. You don't have a gain because, like I said here, you lose more than what you gain back. Alright, for problem number 3, let's let A represent a number greater than 0. You can let A be any number greater than 0. I'm going to go ahead and assign a value. How about 3? A, let it represent a number greater than 0. 3 is greater than 0. And let's let B represent a number less than 0. Go ahead and assign a value to it. How about negative 4? Negative 4 is less than 0. I'm just giving 2 random numbers. As long as that number A is greater than 0, A equals 3. 3 is definitely bigger than 0. B equals negative 4. That's definitely less than 0. Now let's determine whether each statement is true or false. So using these numbers that I assigned here, you didn't have to pick 3. You could have picked 1, 2, 3, 4, 5, 6, 7, any number greater than 0, And back here, a number less than 0 for B, you could have picked any number less than 0, such as -1, -2, -3, -4, etc. So let's write this out and see if this is true or false. A greater than B. Using the numbers that we picked here, we picked 3 for A, greater than B, we picked -4 for B. Is that true or false? Is 3 greater than -4? Yes, it is. So therefore, that is true. Question B. B, we let B be -4. Copy down the less than symbol. And then we have the opposite of B. That means -4. Think about it like this. Negative is that sign there, and then we had B equal to -4. This really means the opposite of -4. So let's go down one more step and write this as -4 less than, the opposite of -4 is a +4. Two negatives right beside each other do make a positive. Is this statement true or false? -4 less than 4, that is definitely true, because a negative number is definitely less than a positive number. This question right here, question C. We have B equal to, B is -4. Copy down your plus. In parentheses, the opposite of B. That's kind of like what we did back here. -B, we said -B ended up being the opposite of what B was. Well, the opposite of B is still going to be what we had right here, 4. And is this equal to 0? Is -4 plus 4 equal to 0? Absolutely. That is true as well. And then this last one right here. The absolute value of B. Well, B is equal to -4, so we take the absolute value of -4 and we're going to see if that's less than 0. The absolute value of 4, recall, if you're taking the absolute value of a number, you want to automatically make it positive. Copy down the less than, copy down the 0. Is 4 less than 0? Absolutely not. 4 is greater than 0, so therefore this is false. So we have a true, 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 false. Be careful with your signs here. And again, as I mentioned, you could use any number greater than 0. It doesn't really matter. I picked 3 just for the heck of it. Over here, I picked -4 just for the heck of it, because that number was less than 0. All right, on to question 4. What happens when you add opposites? Well, -2, what's the opposite of -2? +2. What happens when you add these two numbers together? You get 0. How about +7? What's the opposite of +7? That's -7. What happens when you add these two opposites? You get 0. So the answer to this question is, what happens when you add opposites? Their sum is always 0. Make sure you give a sentence for that answer. Explain that. Just don't show it mathematically, but write a statement there, because it says what happens when you add opposites. Their sum is always 0. Question number 5, right beneath that. A healthcare provider for a company estimates that 75 hours per week are lost by employees suffering from stress-related or preventable illness. What is the effect after 4 weeks? Express your answer in words and as a signed number. So the healthcare provider, they estimate 75 hours per week are lost. Losing 75 hours per week. So for losing 75 hours per week, and we're looking at the effect over 4 weeks, losing 75 is -75. Over the course of 4 weeks, you can multiply times 4. -75 times 4 is -300. However, be careful. You want to explain this. You want to express your answer in words and as a signed number. So our signed number is right here, -300 hours over the course of 4 weeks. However, for an explanation, let's give a quick explanation here. We can say over the course of 4 weeks, the healthcare provider will lose an estimated 300 hours by employees. Something along those lines. Just make sure you are talking about a loss. Over the course of 4 weeks, the healthcare provider will lose an estimated 300 hours by employees. Something along those lines. Just give some type of explanation saying the loss, there's our loss, and the 300 hours. And again, we got 300 by taking the 75 times 4, but in this case it was negative 75 times 4 since you're losing 75 hours. Now what does this problem mean? That's 75 hours of work. So make sure, again, express your answer in words and as a signed number. Follow the directions that are given or that you are being asked to follow. Question 6. Describe the associative and commutative properties. Give an illustration of both. Well, for the associative property, we can look at two different operations. Let's see, associative. Consider 2 plus 3 plus 4. I'll come back and do the other example in a second. And let's group the 2 and the 3. And this is going to be equal to 2 plus 3 plus 4, but we can group the 3 and the 4. The associative property deals with parentheses around a certain group of numbers. Now this applies to addition and it also applies to multiplication. But before I show you multiplication, let's just work this out. This is all I'd want you to show. Describe it. Well, we do have to describe it. So if you describe that, you could say you can change the grouping of numbers with parentheses if you are adding or multiplying, and I'll show you the multiplying piece in a second. But again, let's see why. If you do order of operations here, you work inside your parentheses. 2 plus 3 is 5. 5 plus 4 is 9. So we get 9 on this side, and we work inside of our parentheses first. Well, check out this side. We work inside the parentheses. 3 plus 4 is 7. 7 plus 2 is still 9. So the associative property works. It works for addition. You can change the grouping of numbers with parentheses. That's exactly what we did here if you're adding, but this also works for multiplying. 2 times 3 times 4, grouping the 2 and the 3, and then we can take 2 times 3 times 4 and group the 3 and the 4. Let's do this real quick. Checking by multiplying. 2 times 3 is 6, working inside your parentheses, and then 6 times 4, you get 24. Over here on this side, let's multiply the 3 and the 4 together first. 3 times 4 is 12, and then 12 times 2 still gives you 24. So we have described the associative property, and here's an example here, and then here's an example here, using addition or multiplying. The commutative property, we can do something very similar with addition and subtraction. Suppose you had 5 plus 7. The commutative property lets you switch these numbers around and you still get the same answer. 5 plus 7 is 12, 7 plus 5 is 12. Now let's describe that before I show you the multiplication piece. So you can switch the numbers around if you are adding, or I'm about to show you multiplying. So picking two numbers, we're going to multiply them and then we're going to switch them around, such as 9 times 5. That's the same thing as 5 times 9. 9 times 5 is 45. 5 times 9 is 45. So we get the same answer. Now to hit on this a little bit more to prepare you for future modules, you could get a little bit more, a little bit more abstract by using variables. This works for any numbers. So we could say, back on the associative property, if we have some number A plus some number B plus some number C, and if you group the A and the B, it's going to be the same thing as some number A plus some number B plus some number C with the B and the C grouped. The same thing applies to A times B times C with the A and B grouped is equal to A times B times C with the B and the C grouped together. This is the associative property. Look at this. This example right here, the A plus B plus C equal to this stuff, by changing the grouping, that matches this up here. And then taking just some numbers, A, B, C, it's like 2, 3, 4. If we change the grouping here, the multiplication will still be equal based on what we did right here. These two, we could do similar things as well. Instead of just saying 5 and 7, we could say x plus y, that's equal to y plus x. We just swap the numbers around. X plus y is equal to y plus x. That's what kind of matches that right there. And then this one down here, we could say x times y is equal to y times x. 9 times 5, 5 times 9. Same thing. These ideas here using variables prepare you for future modules because you will be doing some algebra later on in your DMA classes. Question number 7. Explain the steps necessary to evaluate the following. Alright, not only do you need to just do the work, but you want to explain. And explaining here, I'm okay if you just write down maybe 1 or 2 words. For example here, the first thing you want to focus on is parentheses. Think about, please excuse my dear Aunt Sally, PEMDAS. So you want to work inside parentheses. Think of brackets as parentheses too, but we do want to work inside of this set of parentheses right here. So I'm going to copy everything down, but I'm going to change 5 minus 8. That gives you a -3, and this thing is still getting squared. What we did here is we worked inside parentheses. If you just write that down, I'll be fine with it. You are explaining. You want to work inside parentheses. This is showing me that you're following the order of operations. Now we have these brackets, which we want to think about as being parentheses too, but we still want to work with this inside of these parentheses doing this exponent. So that step, 94 minus 3 with a bracket, minus 7 plus 9 with that bracket there. -3 squared, that means -3 times -3, that gives you a +9. What you did here is you worked on the exponent inside parentheses. Or in this case, we could say the exponent inside the brackets. Now, we don't want to do 94 minus 3 yet. That's a mistake that maybe I should have mentioned to begin with. You don't want to subtract until you deal with parentheses and exponents and multiplying and all that stuff. So that's a big no-no. You don't want to combine those. That's why, again, you don't want to combine those. That's why I've just left these alone for the time being. And we're still going to leave them alone for right now. So we have 94 minus 3, but inside these brackets, we now have -7 plus 9. Since these two signs are different, you subtract and keep the sign of the quoted bigger number. -7 plus 9 is a +2. So what you did there is you worked inside brackets. And now, what do we do in our next step? From here, let me make some room. From here we have 94 minus, we don't want to subtract 94 and 3 yet because this is 3 times 2. You could think of these brackets right here as parentheses, as I mentioned earlier. So if you write it like that, maybe it does help you see, okay, you definitely want to multiply these, and that's going to be 6. So what you did there is you multiplied, and then your very last step, 94 minus 6, that gives you 88. You did the subtraction piece to please excuse my dear Aunt Sally. So writing down some words to explain each step, I'm going to be looking for that when I grade your module exam. So be very careful and make sure you do follow the directions. Explain the steps. All right. And tell you what, I'm going to grab the document camera real quick. I might want to fast forward. I'm just going to keep on recording. I'm going to plug up the document camera. We're going to check this one on the calculator because it is a great tool to have, and we haven't used it at all so far in the review, so it's definitely worth using. Maybe you have used it some up to this point, but make sure you are explaining your steps. All right. So I'm going to type this in, but there is no bracket on this calculator, so I'm just going to use parentheses for that. So I'm going to type this in exactly like I see it, and it's going to spit out 88. But again, you have to show these steps as you're working this problem out. Otherwise, you will not receive full credit because it does say explain. So we have 94 minus 3 parentheses negative 7 plus parentheses 5 subtract 8, close it up, square it, and then another parentheses. Rewind the video if you didn't see all that, but I am using, like that parentheses right there that you see flashing is this bracket. But if I press enter, look, 88, we get the exact same answer. Make sure you follow directions. Make sure that you explain. On to question number 8. Are negative 8 in parentheses squared and negative 8 squared the same value? Absolutely not. Absolutely not. Negative 8 squared means negative 8 times negative 8. Negative 8 times negative 8, that's equal to 64. Whereas this one over here, think about this. This is negative 8 squared. The only thing getting squared here is 8. This is a weird idea to grasp, but what you want to think about is this problem being written like this. Negative 1 times 8 squared. These two expressions are the same thing. The only thing getting squared is the 8, so this means negative 1 times 8 squared is 8 times 8. If you take negative 1 times 8 times 8, that gives you negative 64. And the idea behind here is this: if you start using the calculator too much, you're going to forget about this whole idea of using parentheses. It's critical that you use parentheses when plugging in numbers, especially later on when you start approaching some algebraic problems. But the answer to this question, are they the same value? No. It doesn't say explain, but I would like to see you work some things out. But the answer to this problem is no. And again, this is a good time to look at the calculator too and see what's actually happening. Even though I just explained it, but let's have a look anyway. So that first piece, negative 8 inside of the parentheses and then putting the squared on the outside, negative 8 squared, that matches exactly what you have right here. That's a positive 64. Whereas this second one right here, without parentheses, negative 8 squared, what you're doing really is just doing the order of operations. You take the 8 and square it, that gives you 64. Then it's times this negative 1 out here, and that's what I wrote right here. You want to think about it like that. So therefore, we will get negative 64, as you can see right there. Be careful, very, very common mistake. Number 9, remembering that the television size is given by the size of the diagonal. What size is a television that is 21 by 20? Maybe you knew this, maybe you didn't, but if you have a TV, a high definition TV, TVs nowadays are rectangular shaped. They're not square. And when you say you have a TV that's a 50-inch TV, it's not 50 inches up, it's not 50 inches across. It's 50 inches across the diagonal. That blue line is really where you get the word 50-inch or 60-inch or 40-inch TV. So what we're trying to find is the size of a television. How many inches is a television? And it's based on the diagonal, given that the television is 21 by 20. And I'm going to say this is 21 inches, even though it's not listed in the problem. by 20 inches. So what we're really looking for here is the hypotenuse of this right triangle. And if it's hard for you to see that, we do have a right triangle. And let me see here. Let's flip this thing around. I'm making it a little bit smaller, but there's your right triangle, and I'm just pulling it out to show you right there visually. And we can think of this as being a leg, 20 inches, 21 inches. And this right here, the hypotenuse, we call that the letter C. So we use the Pythagorean Theorem, a squared plus b squared equals c squared. And let's plug in our values. It doesn't matter which one's a and which one's b. They're both legs. I'll call that one a and that one b. So a squared, that's going to be 20 squared, plus b squared, that's going to be 21 squared, is equal to c squared. 20 squared, that is 400. 21 squared, that is 441. And this is equal to c squared. We're trying to find c squared. When you add 400 plus 441, that gives you 841. That is not the size of that TV. What you want to do here, since you are taking, or since you have, and I wrote c, but this needs to be c squared. We don't know what c is yet. But in class we talked about this too. The opposite of squaring something is to take the square root of that number. So taking the square root of 841, if you do that, maybe that's one you don't have memorized. Heck, I just had to check it in the calculator. Square root of 841 is 29. That's what c is equal to, because the square root of c squared is equal to c. So the question says, what size is a television that is 21 by 20? Give me a complete sentence. The TV, or the television, is 29. We didn't give a measurement, but I'm just going to say inches. That's how we typically measure TVs. So maybe you didn't know that about TVs. The fact that when you say I've got a 50-inch TV, or in this case I got a 29-inch TV, it's actually the measure from one corner to the opposite corner. It's called a diagonal. That's what a diagonal is, dealing with a rectangle at least. Right, on to question number 10. Explain the error. What is the correct answer? Well, let's see here. I would be perfectly fine if you took the problem and you just worked it out, and then we can point out the error. Doing order of operations. The first thing you want to do, please excuse my dear Aunt Sally, you want to work inside parentheses first. So leave the 5 alone, leave the 3 alone. 2 minus 6, that's negative 4. So you've done your parentheses. There's no exponents. My dear, please excuse my dear, you want to multiply or divide. We got to multiply these two numbers. Oh, there's the mistake. Leave the 5 alone, bring the plus down. This needs to be negative 12. The mistake is right here. This student, whoever worked this out, they took the 5 plus 3 and said 8. But what the student failed to do is they failed to multiply before add. That's that whole idea of please excuse my dear Aunt Sally. You want to multiply or divide before you add and subtract. So here we did multiply these two numbers. Now we can add these two numbers, or you can think of it as subtraction. 5 plus a negative 12, that is equal to a negative 7. And the reason why that's equal to negative 7 is because these two signs are different. When your signs are different, you subtract the numbers and keep the sign of the bigger, quoted bigger number. So 12 minus 5 is 7. 12 is a bigger number. It has a negative sign, so we make our answer negative 7. All right. So explain the error. I explained it verbally. I didn't write it down, but let's just say the student solving the problem added 5 and 3 instead of multiplying the 3 by negative 4. They did not follow the order of operations. Let me move that down so it's not inside of the writing. But again, students solving the problem, they added the 5 and the 3 instead of multiplying that 3 and that -4 first. And we showed that right here in our work. So an explanation like that, definitely want to see it because it does say explain the error. Make sure you explain the error. On to question number 11. We're almost there. Draw two different rectangles. I'm just going to draw rectangles. They're not drawn to size. I'm just going to sketch two of them with a different length and width that are possible for a rectangle with an area of 18 square inches. Find the perimeters of the rectangles that you drew. If we want a rectangle to have an area of 18 inches, think about a rectangle. The area of a rectangle is length times width. How about 9 and 2? Right? And let's see, okay, inches. So how about 9 inches and 2 inches because we want an area of 18 square inches. Well, the area of this rectangle is 9 times 2. That's 18, and we can say inches squared. But also notice it wants you to find the perimeter. So to find the perimeter of this rectangle, you want to add all sides together. 9 plus 9, there's 2 9s and there's 2 2s. So plus 2 plus 2. 9 plus 9 is 18, plus 2 is 20, plus 2 more, that is equal to 22 inches. There is the perimeter of this rectangle. Now, the problem did say to draw two different rectangles. How about 6 inches and what? Think about it. How about 3? Because the area of this rectangle is going to be 6 times 3, length times width, that is still 18 inches squared, or 18 squared inches. The perimeter, let's see what we get for the perimeter here. We want to add up all our sides. So we have 2 6s, 6 plus 6, and 2 3s. So plus 3 plus 3, adding everything together, 6 plus 6 is 12, 12 plus 3 is 15, 15 plus 3, oh look at that. The perimeter is also 18. Ironic, but hey, who said that couldn't happen? I didn't. Sometimes it will. So there you go. Two different rectangles. They have different lengths and widths, but they both have an area of 18 square inches, but notice the perimeters can be different. Back here we had a bigger perimeter than this one. Alright, and question number 12. The directions for finding the location of buried treasures are given below. From the tallest palm tree on the beach, let's walk 16 paces north. So what I'm going to do is I'm going to draw a straight line because a compass is north, south, east, and west. So if we go north, we can go north 16 paces. So I'm just going to say 16. Turn and walk due east. So what we're going to do from there, again, we started right here. That's not where the treasure is. That's where we start from. This is the, palm tree. Not the best artist, but hey. There's our palm tree, 16 paces north, and then we're going to turn and walk due east 12 paces. So turning directly to the right, making a right angle, and we're going to walk 12 paces due east. And then at this location, we're going to dig down 6 feet. Now, reading the problem, we want to draw a diagram, which is what I started to do. What is the distance from the tree to the location of where we need to dig? So the treasure is right here. Now, yeah, we have to dig down 6 feet. What is the distance from here to the location where you have to dig? This 6 feet that you dig down, that is not dealing with the distance from the palm tree to the location where you need to dig. So once you go 16 paces north and 12 paces east, right there is where you're going to dig. That's the location of where you have to dig. So don't make that complicated on yourself. All we're really trying to find is this line right here. So again, this is another Pythagorean Theorem example. This can be A, this can be C or B, and this can be C. Pythagorean Theorem, A squared plus B squared equals C squared. A is 16, we want to square it. B is 12, we want to square it. And then we're trying to find the straight distance from the palm tree to the location where we're going to dig. Alright, so doing that, 16 squared, that is 256. 12 squared is 144. This is equal to c squared. 256 plus 144, that is 400. This is equal to c squared. Now, it is not 400 paces from the palm tree to the location where we need to dig. Remember, the opposite of squaring something is to take the square root, and the square root of 400 is 20. So therefore, what is the distance from the tree to the location where we need to dig? Let's give a complete sentence. It is 20 paces from the palm tree to the location to dig. And I hope my spelling's right off the screen. It is 20 paces from the palm tree to the location to dig. That straight line across. So there's your answer there. Make sure real world problem. Let's give a nice complete sentence to emphasize our answer there. All right, 13. Last one, show your work, perform the following operations. All right, and I'll tell you what I'm going to do. You fast forwarded probably all the way to here. I'm going to stop this video for now because these several problems here are going to take a good chunk of time as well. And plus this video, we're already looking at over 30 minutes. So look for part 2 of the DMA 10 review, and it'll cover these problems and these problems only. So that's it for this video. Hope it helped.